I want to introduce you to R. So if you want to learn R, the first thing you need to do is you need to be able to go to your Google and you'll be able to download the software that you require. So that's what you want to do. You go to R, you go to statistical software, and you have the R project.org as your starting point. I'm going to select the cloud. I'll just take you through the process. And then it shows I have three, the Linux, the Mac, and the Windows. I'm for Windows because that's my operating system. Install R for the first time. That is your first time. And off you go, you click here, and it will download it into your machine. And once it downloads the software into your machine, like it's doing now, then you just click the file that has been downloaded, and you'll be able to install the software. And once that process is complete, the next step you go is now you want to download what we call the IDE, and I prefer using the RStudio, so I go to Google and I look for RStudio. Download the RStudio IDE. So if I click there, it will take me to RStudio. And if you want to think about RStudio, you think it like an editor, just like the way you have a Word document. It will help you type and save all what you're doing. If I go down, I have 4 options here. I'm going to pick the RStudio desktop for free because I'm not using RStudio. I don't have the RStudio server, so I have a single machine, and I'll click download, and there it will download for me. So what have we said? The first step is you download R. It's downloading still, but you download it and install it. Once you have done, you come and download RStudio and also install it. Having completed the R and RStudio installation, we normally work from the RStudio environment, and I'm just going to briefly mention a few things that we have. You see that your window has 4 sections that we want to keep track of, and one of them is the first one here. This is where you write your code in this section. This is a section to write your code, all the instructions that you want to be executed by R. This shows you the history, the second window. You can see here it has the environment, it has the history showing you all the activities going on. And then you also have the third section or the window. This is a place where you can get help on some of the commands or the instructions that you need to remember. The R documentation is found on this section. You can install packages from here. We'll be talking about package installation in a moment. And then the fourth one is the console, where whatever you are doing up here, for example, if I come to the first part here and say I want to assign x as 2 plus 2, I know that the answer is 4, but it just tells me. So if I come down on the console and click X, it tells me that the answer is 4. So now with my 2 plus 2, I can save it. Why the less than and the slash sign? That is, I'm telling my R that I want to store X variable as a sum of 2 numbers. You can write it that way, or you can write it this way, but most prefer putting it as that sign, because sometimes the equal sign sounds like it has to be always equal. So we prefer the first one, because when you're dealing with data, it's more fancy. We'll talk about that later on also, but for now, this is the console. This is where you save your code. This is where you see your history. You can see the activities I've been performing being shown here. And then on this section, it tells me a number of things. For example, I'm looking for a certain package or command. So for example, if I just say, I put a question mark here and say tidyverse, then I enter, then it will appear here. Now it could not be found because I've not called the library. So what do I mean by calling the library? Now when it comes to installing packages, as you move along learning R, you realize that you need a package for everything. So for example, I know a package called tidyverse, which is very good for data manipulation and wrangling. If I click here and click install, it will install with the dependencies. That one. And I can choose the clan where it will come from. At this point, I want it, this one has been set through the settings. So if I say install, it's going to install. This is the easiest way. Alternatively, if I wanted the package, I could have come down here and say install.packages, and then I type tidyverse. Then I'll enter and it will install the package. Once the package is installed, it is saved in a folder, a certain folder or directory in your machine. So for you to be able to use it in R, you have to come and call it. I've not installed because it's already installed. There's no need. So because I want to use it, I'll come and call it. Then I can click on it and then control enter, or click on it and then use other commands like this one here and the current line, and you see it says all selection control plus enter. So if I sell it, it will just call the package. What do we mean by calling the package? It gets it out of the directory in your machine and it brings it to RStudio so that you can work with it. Now with that, I can check different commands that I know or functions that are in tidyverse. For example, I can ask what is slice. Slice is inbuilt as part of dplyr package and also in the tidyverse. Tidyverse composed of a number of packages. So when you do all this, then you're able to work. Remember on the history, it shows you all the activities that you've been performing. So that gives you an overview. The other thing you could do is, without even starting to learn much, is you could go to the global settings and you could change the appearance of your screen, the sound, the font size, the colors that you'd want. You can come and change them here. You pick what font size here and so forth and so on. You could also, that is if you'd want to change. I don't want to change mine, but you can come and check here and then you go to appearance. Then check zoom 175, the dim, and so on. So this is all up to you to decide how you would want it to look like. But mine, I'll leave it as it is. The other thing I could still do is I could come to tools, go to global options, and then I come to pane layout. What do I mean? Remember, the pane layout, I have 4 sections and they are all being shown here. I can decide to change how they appear, and they will have some changes in them, and that will also have the layout changing a bit, and that depends with you also. So if you feel you want to do a few changes, then you could do that and you'll get it. So I'm not going also to change, but I also leave that for you to check through and do, meaning that you could move this where you're writing your code to your right hand side. You could move the console and take it also to the right hand side, and move the environment from the right hand side to the left hand side. You could interchange them if you go to the global options. The first thing I'm going to do is I'm going to save my file, and you can see it has created a name basics.r. One of the things that I find very important is you put a comment. It was written by Davis on a specific date, you can give the date, and you can also say what you are doing in this script so that you can be able to code. Maybe I want to look at basics of R software. For example, if I say X, so I want to create a vector and I call it X, and I say a sequence of numbers from 1 up to 20 with a difference of 3. So I want to create a sequence of numbers from 1 to 20 with a difference of 3. If I do the control enter, which is up from here, then the current file or selection, control plus enter, then it will give me down there on the console, I have X and I have my sequence. Smallest number is 1, then 4, 7, 10, 13, 16, and 19. 1 with a difference of 3 to a maximum of 20. That gives me a sequence of numbers. What about if I wanted to create numbers that maybe are negative? I could have said a sequence of numbers. Maybe the smallest is -5. I want to go all the way to 5 with a difference of 1. Let me see what type of number I'll get there. If I say x1, it starts with -5, -4, until +5. I could also have them in decreasing form by saying sequence by is equals to maybe -2. I start with 30, decreasing by 2 until number 6. From 30 with a difference of 2, 28, 26, and the lowest number should be 6. So that's how many numbers are in X. It tells me there are 7 numbers. And if I look at X, actually there are 7. It's 1, 4, 7, 10, 13, 16, and 19. And that is a total of 7 numbers that I have. What is the floor of a number like 2.448? Look at the relationship, the floor, and the ceiling of 2.448. Same number. You see that the floor gives you 2, the ceiling gives you 3, even though the number is less than 2.5. So the floor takes the number down to a full integer, the ceiling takes the number up to a full integer. So that's the difference. The mean of X, that could give us the mean. The mean of the sequence X, of that sequence of numbers. I could also get the standard deviation of X. I could also get the square root of X. It gives me the square root each of the numbers. You can see the square root of 16 is 4, the 19 is 4.35. And so I take X and just square it, and it tells me that X2, I square each of the X number, so it's 1, 16, 49, 100, 169, and so on. So I'll call it M1 for my matrix, and I'll use the command matrix. I'm going to concatenate numbers between 1 and 9. So I'm creating numbers 1, 2, 3 until 9. And I need my matrix to be, because it has 9 numbers, I want it to have 3 rows. By row will be equals to true. What does it mean? So I have numbers 1 to 9. I want my matrix to have 3 rows. And I want it to put them by row. So the first row will have 1, 2, 3. The second row will have 4, 5, 6. So we can see what happens. And there I get my M1. You can see that the first row has 1, 2, 3, the second one 4, 5, 6. What about if I said by row is false? So I'm just copying that, change that, and then here instead of saying true, I just say false. And what happens with my M2? Let's find out. You see, there's a difference now. Because I said by row is false, it writes the numbers by column. 1, 2, 3, the first column, 4, 5, 6, the second column, and fruits. And I'm going to create a combination of fruits. I can have oranges, I can have mangoes, I can have guava, I can have melon. Let me just have those 4 oranges. And there I can check what class are these fruits in the character class. I can also check the number of characters in the fruits. So for each of the fruit, how many characters? So oranges is made of 7 characters, mango 7, guava 5, and melon 5. And that would also create numbers instead of characters. I could tell it give me numbers from 1 to 20. This is also a vector. And if I try to check the class of numbers, you realize that they are integers. Yes, I have 1 to 20. Those are my numbers. I can use a colon to write them down, and that tells me that those are numbers. What do I mean by that? I want to start off with an example. I'm going to call it F, and I want to create one where I'm dealing with male, female, male, and the other one will be maybe male, and maybe then just let me have 5 of them. Let's try to check the class of this. It tells me they are characters. So what I do is I introduce the word factor to make them factors, to categorize them. As I would expect them to become categorical data or factor data as we use it commonly in R. So if I say class of F, I find that it is a factor. Levels of F. Now, you realize that it's telling me that I have 3 levels. Why? Because one of the male is written with a small letter. So what we do is we make it a capital letter so that it fits into the other. So now number of levels will go down to 2, and that is BMI. So the first thing is it's a data.flame. And one of the things is gender. I can see gender C is equals to male, female, female, female. So I'll assume that in my data set, I have 1 male and 3 female. So I can have the gender. I could have their age. Age is a number, so I don't need to put it in quotes. So there are 4 of them. Again, a comma. Maybe I could put in their height because I'm interested in their BMI. And the height is also a number. I'll put it in centimeters. There are 4 of them, and maybe then their weight. So that should give me the weight in kilograms, and I could have 89, I could have 68, I could have 75, I could have 52. So that's the data that I have on BMI. I should be able to see my data down here on the console down that I have my BMI. So that's my. So these are some of the basic commands that we could find very common in. So today we want to give ourselves an overview of what we refer to as the data types or the data structures in R. That's what we want to look at. And the first one is what we refer to as vectors. I've written an example of a vector and I'm calling it apple. There are 3 colors of the apple. And I'm looking at using the letter C to concatenate, that is to combine them together. And because these are strings or characters, I have to put them in double quotation marks. And so if I click my vector, I look at it, I see my vector as the first word led as 3 characters. NCHR is the number of characters. Then we have green with 5 and yellow 6. So if I just want to see what is in my vector apple, I just type apple there and it tells me I have 3 colors. That is how we write a vector. I could also write a vector of numbers. For example, I could say just give me numbers from 1 to 10, and this is also a vector. So when I say NOS1, it tells me I have a set of numbers. The other type of data type is a list. A list, you have many different types of elements. So I can have I can put numbers 1 here, the numbers we got there. I could also put apple here. Remember, there's a difference putting apple under double quotes and apple without any quotes. Let's see the difference so that we understand what it means. Now, these are the items in my list. Starting with number 1 is the numbers 2, 4, and 5. 2 is the word apple. 3 is the word female. 4 is my vector in line 8. And then 5 is my vector in line 6. So when I put down apple, that is the name of my data set. But when I put apple under quotes, that is a word. So that's the difference between the two. The other one is matrices, dimensional. We can look at them. Here I have a sequence of numbers starting from 2 with a difference of 3 up to 11. So that is 2, 5, 8, and 11. So there are 4 numbers. I want it to give me a matrix that I'm calling M1, and I want by row to be false. The other one is also a matrix with letters A, B, C, D, E, F. So if I check M2, it tells me that is my matrix. And from the matrix, you can do other things that will come later on. You could also get the determinant of M1. So if I try to get the determinant of M1, it tells me is negative 18. I could solve M1, that is to get the inverse, and that is the inverse of that matrix. I could get the dimension of M1, dim of M1, and it tells me it's a 2 by 2. The other data type that we have is an array, and I'm taking my matrix M1, and then I want it to be, so it's my M1 is 2 by 2, so that's why dimension is 2 by 2, and then it should repeat the matrix 3 times. So if I come and type array 1, then it tells me it will repeat my M1 3 times. 2, 8, 5, 11, 1 time, 2 times, and 3 times. Remember, instead of going down there in the console to type, I could just be putting my array there. So when I control enter there, then control enter, it gives me the output. I don't have to go to the console. I can decide to put the name there, and then it will just read the name automatically. The other one is what we call the factors. Let's look at this. It's male and female, so there are 2. So if I ask which class is F, it tells me it's a character. How many number of levels? It tells me there are 0. Why is it saying there are 0? Because it does not recognize my line 30 to be a factor. So I decide to do the same, but now I call it FF, and then I tell R that I want that data to be factor. So let's find out. When I ask for the class, it tells me it's a factor. Now, if I came and asked how many levels are there, it tells me there are 2, because it's a male and female. So here I could move this. If, for example, I changed one of the names to be a small m, so male capital M and male small m, then my data will assume I have, yes, it's a factor, but now it will assume I have 3 levels. I have a male with capital M, male with small m, and also the female with capital F. So it assumes I have 3 factors. So this is what we call categorical data in very simple statistical language. There's another one there which you can check, and it tells me there are 4 levels: P, U, T, and S. Those are the 4 levels. Apart from what we have looked at, the final one we want to look at is what we call a data frame, tabular form, and I want to create one. And this is how I would come up: their gender, their 4, their height, their weight, and the education level. Instead of going down there to type, I just put the file name here. This is the file name. I've used my name, doesn't matter. And that is how my data looks. So these are the data types or the data structures that we find commonly in R, and it's good to have an understanding on how they differ. Now, before I conclude, I want to look at data sets that are normally available, so I'm able to view them. So what are these? Now, if I come down there in the console and say data sets, and I put double colon, it gives me a list of all the data sets that are normally installed with the base R. When you're installing your R software, these data sets are also installed. All this. They are open for you to use. And the data I'm pulling up is what I call the IDs data set. So I said I want to name my data IDs just like the way it is named in R. Then I want to view. To view is to see it. I can see it has 4 columns. It tells me showing 1 to 10 of 150. It has 5 columns and 150 entries. So there are 3 types of species of this iris. There is setosa, there is scala, and then the virginica. And they are giving the sepal length, the sepal wing, the petal length, and the petal wing. Now, when I say class, I want to see what data structure is this. We talked about the data frames, that is the most common. We'll be talking about others later on. And the class is a data frame. I can tell it to show me the first few entries. I tell it to show me the head. And what happens, it will show me the first 6 entries of my data set. If I say to show me the tail, it will show me the last 6 entries of the data set. You can see the last one is 150, and that is what we have. Then finally, just to give you an introduction, is how to install. One of the packages that is commonly used for data manipulation is what we call the tidyverse, and we normally say install.packages, and then we can also say dependencies is equals to true. And so once you do that, it will install for you tidyverse. Once it does install it, you have to get the tidyverse from your system and bring it to RStudio. We use the library. And this is what we have just done. We have looked at the tail and the head. What we did not look at was the summary. So let me just briefly look at the summary of the iris dataset, the sepal length, the wings, each one, and the species. Each one of them has 50 entries. And these are the summary statistics. Summary statistics are the descriptive statistics as they are commonly known. Let us consider how to read and write data using R. And the first thing I want to do today is to show you how you can set the working directory. So you go to session, set working directory, choose directory, and then you go through and you get the folder where you have saved your data. You can come and copy it. You copy the folder. The first type of data I want to read through is the CSV type of data, and it's called the mobile money dot CSV. And I can even view it. And that is my data that I have called the mobile data. Now you note that I have not installed any packages because the read.csv comes together with the main software. So the CSV data, that will be easy. Now let's look at Excel data. And I want to read the Excel data. The first thing is I want to do the installation of read.xl, which I already have. I have a data set called bank, and I want to read the data from that, read underscore xls, and then I'll look for the bank.xls. that's the data, the name of my data. And you can see I have been successful. So what do I have? That is my data. And I can now comfortably, if I wish, I could decide to save it in my machine, not just as bank, but maybe as new bank. Let me call it new bank.csv. So now I can save it in my computer as new bank.csv, so that in future I don't need to look for the library XLS if I want to work with the data. We want to look at SPSS data, and for us to be able to succeed in doing so, we need to introduce the package column to be able to read the data from SPSS. So if I say SPSS, I've just got the library foreign because I've already installed the package before. Now I want to read my data. I'm calling it SPSS. So read.spss, and it's called fin access underscore SPSS underscore project underscore 9.sav. That's the first step. And the second step is use.value dot labels, and I say that should be true, and then dot data dot frame is equals true. What do I mean? I want it to give me the actual names. If it's male, not to give me a 0 or a 1, but I want the word male. And then I also want it to be a data frame. That's okay. We can view the SPSS file so that we see we have been successful in importing it into R, and that is my data. Now, so that's what we have. And also, if you wish, you could write it again as you have done before. SPSS, you can say it's called new SPSS.csv. And what will happen is that if you go to the folder, you realize that now you have saved your data in SPSS from SPSS to a CSV. And so these are a way that we can use to read data. We want to look at the dplyr package, and we want to look at those verbs, the 5 of them. And I want to use the IList dataset that we have. And for most of us, or some of us who are familiar with it, we can pull it out easily in that way. And that is the dataset, the sepal length, the sepal wings, the petal length, the petal wings, and the species. Those are the 5. I have 5 columns and 150 entries of the data. So you can go through the data set and have a look at it. But I want to take you through on how to go and do a number of things. So you can call it IDs to arrange data set. So I'll pick the data. I introduce the pipe. I want to arrange maybe my data set with a specific. Maybe I want it to be sorted in a specific form. Maybe I want the sepal length to start in descending form, starting with the highest value. So what I'll say is descend sepal length. And if you view that, the it is arranged, you see it starts with the length being the highest is 7.9. So it challenges with the length of the sepal length in descending manner. So that is one of them. That is the arrange. And then I could also filter. I could always also do this filter. I can say I can use the command to filter, and I can filter based on specific conditions. For example, if you look at the data IDs, I have Setosa, the species. I have 3 species, Versicolor and Viginica. So maybe I want to filter using Setosa. So I just say filter the data, and then I specify that I would be interested that the species. Can see. So I just say species is equals to Setosa. What it does basically is it filters every other data. If you look at this, I have 150 entries because Setosa is 150, Versicolor is Setosa is 50, Versicolor is 50, and Viginica is 50. That makes 150. Now, what about the one that filtered? What happens? Let's find out. They're only 50. It only filters with Setosa. So that's how I can use the filtering to give me more power into my data. The third one is mutate. I call it this mutate. So I take my original data, I create a pipe. And maybe what I want to do this time is I want to divide the sepal length and the sepal width, for example. And then I create another column. I'll call it sepal dot length dot width, and then I'll say this should be equals to sepal length divided by sepal width. And so what it does, let me move it down here. What it does is it creates a column. It creates for you a new column. And we can also view that. That's what we have. And that makes life a little bit easier. So what it does is takes the length and the width, 3.1 divided by 3.5. It has created another column for me with the entries that I have. And therefore, that's what the purpose of mutate is. It has created for me another column. The fourth one we have now is rename. For example, I can decide to rename the columns, particularly, for example, the last column that I have created there. I can rename it. I can do it in a separate, or I just pipe and then say rename. The purpose of this is I want to change the name of the column that I have so that I come up with a new column name, maybe a more fancy name than what I have, or something similar to that, so that it gives me something of a feel. So for example, I can say I want to rename sepal length width. Maybe I want to call it something like LW, for example. And let's see what if it's going to work. It's complaining, meaning maybe I should have done things the other way, not that way. So I should give it the name. So if I view, so I say it is mutate. Now what happens? It's no longer called the old name, but I've given it a new name. I've called it LW, length width, or I could have called it sepal LW. So I say sepal dot LW length width is equals to that. So I've changed the old name and I've renamed and given it a new name. So the renaming helps us to pick and a column and change the name of the column. I can change as many columns as I wish. In this, instead of having species, I can give it a different name. Instead of calling it petal.wing, I can give it another name. So I just use the rename function to help me achieve that. And then finally, want to look at the ID select, and it's a very good verb. It helps me select specific columns. For example, I'm only interested in the length and the species, or the length I get alone. I just say sepal length, comma, petal length. It only selects for me the 2 columns in my data. So the purpose of select is to select for me specific columns of the data. The last one maybe that I did not mention here is the one we call slice. Slice is basically more involved in, for example, when we look at this, we have 150 entries, 150 of them, and we have 2 columns. Maybe I just want the first 20 entries, so I can just come here and put a pipe and say slice from 1 to 20. So what does it do? It gives me the first 20 rows of my data set. And so if I view that, you can see there are only 20 entries. Now I have reduced them to 20. So the purpose of the slice is it looks at the rows. The select, it looks at the columns. Rename column names. Mutate is you are introducing a new column. The filter, you have interest in specific entries in a column, and then the arrange is how you want it. Do you want it to be in descending, in ascending manner? Then that's how you go about it. By looking at 2 data sets from the HAL base, that is the Beaver data. And before we start off, we can just have a view of how the data looks like. It gives the day, the time, the temperature, and a 0 and 1. And so we want to do a few things using the tidyverse package. We want to filter active as 1, then sort in ascending order and create a new column called TA. That is a product of temperature and active. So I'm calling it beaver underscore all. So I'm going to filter active is equals to 1, then I allege in descending. So I put negative temp. And the last thing is I want to mutate, that's create another column. And I'm going to call it TA, which is temp times active. So if I was to check the difference, you find that now this was the original data with 4 columns, but now I've created another set with 5 columns. TA is the multiplication of temp times active, so the values will just be times 1. I've removed the active as 0 from this side, and I'm left only where is equals to 1. So that is something I've done using the tidyverse package. I did the filtering, I was able to arrange, and also did mutate. So I want to mutate time to convert minutes into hours. Remember that if you look at your data, the time is in minutes, 840, 850 minutes. So I want now to come back and do that. So I'll just create a column called capital time. Then I take the time and divide by 60. And if I was to do that and check what I get, and I'm going to look at time, and you see I've created 840 minutes is 14 hours, 850 minutes is 14.166 hours, and 900 minutes is 15 hours, and the list goes on. So that's what we do. The next thing is select columns that start with letter T. So I say select start with T, and that will give me that. Summarize time and temperature to find standard deviation. Summarize all standard deviation for columns that start with how many columns start with T is the time and the temperature. So those 2 columns, I'm going to get the standard deviation. And na.rm is I remove any and a's that are in the data as I do the analysis. The next step, convert all columns to uppercase, select all TO to upper, TO upper. That means it converts all the columns to uppercase. The other data that I'm going to use is the empty class. We can view the data. And this is the data that we have for the empty cars. Now, you could be asking, where is this data coming from? Now, if I come to down here and say data sets, then I put column, it gives a different data sets that are normally installed when you're installing your R. One of them is the beaver one that you have seen, which is a body temperature series of two beavers, 0 and 1, active. And then the other thing, set of data is the empty cars, which I'm going to look at. And they are all part of this. So you just call them directly and you get the data. So I want to arrange by data based on QSEC, and that's in ascending order. Remember when I was doing it in descending manner, that is previously here, I had to put a negative. When you want it to be in ascending, you pick the column, but you don't put any sign. But if you want it in descending, you put a negative before the column, the variable name. Then I can filter data with gears at 3 and 4. If I may go back again, uh, you look at the gears, they are different. There is 3 and 4, 5, and so on, 3, 4, 5. So I'm only interested in 3 and 4. So if you view that data, you see that I'll have filtered based with those two. And those are just some of the examples of how we can use the tidyverse package, which are the different verbs to be able to help us in uh, reorganizing or manipulating our data. Consider to manipulate, to wrangle, and also to visualize our data. I have 4 libraries: the tidyverse, the schema, the tidyr, and ggplot2. I have a certain data I'm calling mob. After viewing it, this is how my data looks like. I'm going to pick a few of the columns. So I skim through the data, and the purpose of skimming through the data is to help me to see. Let me first of all see the uniqueness of the data. Gender, there are 2, male and female. Mobile trust, if you trust the mobile money, there is no, there is an empty space, there is S, and also there is negative 97. And that helps me to see that. And then the account type. If I want to view the account type, I have a number of account types. I have a sub, I have VSLA, I have a mobile money, I have a bank account, I have non, MFI, and online bank account. So the first thing I want to do is I want to remove the empty spaces, and that's why we are using the tidyr to help me do so. So I'm going to say an A if it's an empty space, and an A if it's a negative 97, and then I say drop an A in the mobile money trust column. Then I introduce the dplyr package. Why do I want to do that? I want to shorten the column or the column called account type, because now if I view mob1, you see that I have 3 columns: gender, account type, and mobile money trust, and I have cleaned up my data. If now I was to go and check it again, particularly on the one on the mobile money, so if I say mob1 and then I say account type, now I have only that, which is good. The other one is gender, which is 2 as it was also, but the one that had challenges is the trust, and now I have only yes or no. I have been able to drop out the empty spaces and the negative 97 that was appearing. As the other thing I want to do is I want to change shorten the names. I would like to shorten the names. The circle account, I call it SA, the VSLA account, and so on. And that's what I do here using the mutate case 1. I give the names down there for all of them, and so this is what will happen. My mob changes the name. So now if I work on this. Let's see what happens. You see everything now has been put in short form. Our next step is now we want to do a summary of the data based on gender and account type. And what we get after doing that is what we call gen account. And what does that do? It creates for us a table with some of the entries, the female and the male, and the account type. Count how many were they for the female, those who use the bank account 174, which constitutes 13.3%, and so on. Then the next step, I install the library neatrr and I use the cabo. The purpose of the cabo is to help me create a well-looking table, and this is the table that I'll generate with that. So cabo, then you give the file gen account, and I want a format that is in simple form. My next step is to have some plots or to draw some graphs, and so I have two. I have the geom point and also I have the bar graph. For the geom point, I'm using gender and account type, and for the bar graph, I'm using the account type, the percentage, and I fill with the gender. So after plotting those two, then I would go ahead and combine them using the library ggplyr, and the purpose of this is to be able to put them into the same graph, to put them in the same A4 size paper. So that's what I've done to the two graphs. So in general, what I was doing today, I was trying to look at how you can read your data, CSV data. You can check the factors in your data. You can remove the empty spaces and the numbers that you don't require, that is the cleaning up of the data. You can edit the columns, the entries in the column. You can plot graphs, you can draw tables, or you can summarize the data in table form. Then you draw your graphs. After drawing your graphs, then the other thing you could do is combine them, and we are going to see how this looks like. This is the output of the graph that we had, and it is in a PDF format. You could also have it in a JPEG, and therefore you are able to put many graphs into one A4 size page. And today in this video, we are interested in looking at summary statistics, or what we call descriptive statistics. And we want to use a dataset, the high-risk dataset, to do a few things. So that's the dataset. We have renamed it as DF, the IDs dataset. If you want to know where to get it, if you come to the console in RStudio and you put in, and then you see a list of the datasets that are installed when you're installing the R base. So that's the one we want to look at. So the head will give you the first 6 observations, and we can see there in the console also. Then the data type, the structure of the data, it tells you that the sepal length, the sepal winged, the petal length, the pental winged is numerical, while the species is factor. It has 3 levels, and then that is the data type. And then the structure, it tells you that we are dealing with a data frame. If you wanted to view the data, I can type view with capital V. If I say DF, and that is the IDs dataset that we are talking about. It has 150 entries, it has 5 columns, and there are 3 species. Each species has 50 values or entries: Setosa vescala and Virginica. So, having said that, we want to do some summary statistics. What we mean is we are getting the mean value, the median, the standard deviation, the minimum, the maximum values, and we have 2 packages that we want to use. So I want to remove the species column. So if I was to view df2, that I've renamed, you realize that I've removed the last column using the select function that is part of the tidyverse package. I can do start sum, which is start.descriptive or df2. And if I type down here start.sum, it gives me the various summary statistics for the 4. There are 150 entries and so on. Some might not make sense to you. So what you do normally is you could end up picking a few that will add up to what you want to do. So I want to introduce another library, which is the neatrl, because I want now to organize this. And so what I want to do is I want to select specific values, 1, 2, 3. I want to pick the minimum value, number 4, maximum, and the age, up to 6. Then I pick the median, I'll pick the mean, and so forth. Then I pick the confidence interval for the mean, and I pick the standard deviation, and these are the numbers that I've picked here. So if I was to run that, this is what will appear as my table. I'll pick the minimum value, maximum value, the age, the median, the standard deviation, and the confidence intervals for the 4 columns of the data. I have given it a caption, the title of the table, the height is dataset summary statistics. Remember, I picked this from the part that have previously been populated here or been computed there. I'm using the format simple. There are different formats for the cabo function. There is a pipe, there is a simple, HTML, LaTeX, and RST. I'll not go through all of them. Allow me to do that. And then I want the values to be in 2 digits. If I remove this, it will give me so many decimal points. And then the column names, I can define them as sep.length, sep.width. That way you could rename them to what you want so that they'll appear there in the table. So I'm able to output my values neatly in a table with the different values that we saw. I picked them from the analysis that I have done previously. So that's what I could have done to have some summary statistics from whatever I'm doing. Other ways of getting summary statistics, I want to use the same data. This time I want to summarize. I want to group by the species. So if I come and type df3, and what happens, we can see it tells me I have 3 species. There's a sepal length, the mean value, sepal length, the median, and the sepal length, the standard deviation, sepal length, the mean value, and the list. So you can output them from in a table format. And that's what I've said. I said group by species, summarize across everything, list, you have the mean, the median, the standard deviation, the mean value, and the maximum value. So if it's the sample length, it will give me mean, median, standard deviation, this is median, standard deviation, mean, and maximum. The sample width, the same case, the petal length, and the petal width. And if I want to view, this is what will happen. I have a lengthy table with all the different values as I was mentioning them. So this is where now I'm more interested to see which species has longer. So for example, here if I look at the sepal length, the Virginica species has the longest sepal length. And is it the same case with the sepal wing? Yes, we have one here. And we can see the biggest, the one with the highest, longest sepal winged is the first one, the Setosa species that we have, and so on. So from this, you can do your discussions if you're doing some analysis and so forth and so on. So that's what we have. And then you can also look at the summary of the original data set, which is the iris data set, and this is the summary statistics. If I just use the command summary, that is what I'll get. Frequencies and percentages, I want to use a dplyr package because in the dplyr package, there is a data set called the Star Wars, and I call it Star. I want to view the data. That is how the data looks like. I'll not go into a lot of details also about the data. You can install the dplyr package, and then you get in this data set here. That will help you to do whatever you need to. If you're not too sure what the dataset is all about, you can go to Google and check through. Now, what I want is I want to select three columns: sex, height, and mass. Sex, height, and mass. These three columns. So that's exactly what I'll do here. And then I group by sex. Why am I grouping by sex? Because sex is a categorical variable, or it is factors, none, male and female. And I say to remove any NAs that is not a number in the data set should be removed. You can see them appearing here and there. NAs, NA dot omit removes them. Then I wanted to summarize the data in frequency. It gives me how many are male, how many are female, and so forth, and so on. So if I was to view this, what we are calling star 1, I see female, they are 9, male they are 44, hermaphrodites are 1 and none are 4, and the percentages are given by utilizing the mutate percent. It takes the frequency that they created in line 55, it divides by the sum, and then it multiplies by 100 to give me the percentage. I'm able to get a percentage. I could do the same by just saying table factor. It tells me the group in each category, just like we had before. But this time you note that they seem to be, some value seems to be more. The reason being is that we had not removed the NAs. What about if I want to compare two columns, sex and gender? In this case, I can do table as factor, sex, and then so it tells me female who are feminine, they are 16, hermaphrodites who are masculine is 1, and male who are masculine is 60. Those who are none in the two categories, they are feminine is 1 and the masculine is 5. So we can use a data set to just get some summary, descriptive statistics, percentages, and also frequencies. You can get tables. You can also visualize. We are not going to do that today. Another library is the Palmer Penguins. We could view the data, penguins, and that is the penguins data set that we have. We can easily get it, and these are the different types of penguins. There's a species, their island, the length of the bill, the wings, the depth, of the bill, and also we have the mass, the sex, and the year. And that's the data we have. So if I do this, let's see what happens. It allows me to look at the data in terms of this output here, X tabs, species. There are 3 species and they are from 3 different islands. Some species are not found, some are found in all the islands, others are found only in a specific island. Or I could have done table, it will still give me the same results. So X tabs and table gives me the same results. What about plot table? It gives me this, I multiply by 100 so that it gives me the percentage. So underline species, yeah. These are the numbers. This percentage is out of 100 for all together. That's why this is 12, 16, 15, 19, 36. If you sum that, you get 100. Or I could have just gone looked at the penguin species in each of the 3 species and the number that we have. And so the majority are then derived and found by the Ginto, and then the chin strap is the last type of species. Want to look at the basics of R programming using the loops and functions? And we have simple coding that has been set up for us using for I in 1 to 10. Then we are saying we print I squared. And when we check at the console after executing the command, when I is 1, when I is 2, it's 2 squared and so on. And the second one, we want for I in 1 to 15, we want to print the word hello world. So it's going to print the word 15 times. And if we execute that, we are able to see the command and the output. Next section, we want to look at simple data frame and what is happening in the data frame. We have for numbers 1 to 12. We track the numbers as I, which is 1 to 12. We get the square, we get the cube. Then we create a data frame to put the number, the square, and the cube. And we are going to name the columns as NOS, SQ, cube, and then we print the result by doing an al bind of the result that we have and the data frame. So let's see how that comes out. And when I say to view, that's the result. I have the number, I have the square, and the cube for the number. And so those are the numbers that I have. I have the square of 12, 144. The cube of 12 is 1728. So that's what I would be able to perform with that. So when I say view results, then they'll appear there. The next thing we want to do, we want to look at numbers not equal to, so for I in 1 to 100, if I you divide by 3 and the remainder is equals to 0, and I you divide by 7, the remainder is equals to 0. So we want numbers whose a number that can be divided by 3 and 7 at the same time. Let's see these numbers from the output. And the first number is 21. 21 divided by 3 is 7, remainder 0. 21 divided by 7 is 3, remainder 0. 42 divided by 3 is 14, remainder 0. And 42 divided by 7 is 6, remainder 0. And that's the number we get. Now, what about number not when you divide it's not equal to 0? For example, now we want the numbers that are not divisible. That's why you put exclamation mark and the equal sign. Not divisible by 3. We know them, starting with the lowest. Let's look at the lowest number that we have. And it gives us an idea. Yes, we have 1, 2, 3 is not there. We have 4, 5, 6 is not there. We have 7, 8, 9. Because 8 divided by 3 is 2, remainder 2. So that's why I'm saying it's not equal to. So print for us those numbers. Another one is on Fibonacci numbers. And we have an example here. Fibonacci numbers, the sequence is 1, 1, 2, 3, 5, 8. So it's 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, 13 plus 21 is 34, and that's exactly what we want to do with this function here. And down there up to maximum of 10,000, these are the numbers that we have. We have 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. So that's the procedure you would take to come up with that. We want to use the while I is less than 11, print I. And for me to be able to use the while, I need to track the I starting from 1, then I do it at an increment of 1 until the results are less than 11. And so it gives me a printout of numbers between 1 and 10. We can also use the break statement. It prints numbers before the given number. So for example, I have number 1 to 16. I'm saying if I is equals to 6, you break and then you print I. So what does it do? It will print all the numbers up to 5, and then it stops when I is equals to 6. So that condition might hold, it might not hold, depending with what exactly you are doing. You can use the next, apart from the break statement, you can use the next statement also for I in 1 to 15. If I is equals to 6, then next, and then you print. Let's see how the results will come out. And you see the difference. So it does 1, 2, 3, 4, 5. When I is equals to 6, it skips and then it moves on from 7. So the next will skip that specific number that you want, while the break will stop when you you realize that number that you have put there. You can use a repeat loop. Repeat print x is assigned as x plus 1, and if x is equals to 6. So it goes increasing x with 1 until it gets to x is equals to 6. So that is how we can use a repeat loop. And you can see it gives me 1, 2, 3, 4. If it's at 6, it will stop there. So these are different ways of developing small codes that can help you automate your processes of data analysis, which is very important. The other thing we want to look at is what we call functions, user defined, calling a function. I'm calling this function Davis, and I'm saying a function is a function of A. Then I say for I in 1 to A, then B is assigned as I squared, then I want to print B. Now, how does this work? So if I was to execute the command, you see that there's no results. So I can decide to define the function. And there are ways of doing that. If I was to say Dave is 5, what have I done? I've said Dave is 5. And when I say Dave is 5, what I'm basically doing is I'm defining my A to be 5, because I'm saying Davis is assigned as a function A. So when I say Davis 5, I'm saying I want my A to be equals to 5. Then I say for I in 1 to 5, then B is equals to I squared. So for I is 1, B will be 1 squared, which is 1. For I is 2, B will be assigned as 2 squared, which is 4, and then it's printing. I could have decided instead of say print B, I could have said I want to assign I to be I squared, and then I remove this. It will still have worked for me, and it should work for me. So I'm going to rerun the code again, and here I'm going to type maybe Davis, and maybe let me put 6. Allow me to do that, and you can see we are getting the exact output. So these are what we call user defined or calling a function. So, and this is what you get. So we move on to the next part, which is normalizing, and I want to normalize that. And I have defined a sequence of numbers, y1 as a sequence of numbers from 1 to 9 with a difference of 1. And then I have y2 and I have y itself. Let's see how the numbers look like. Yes, from 1 to 9. And then the second set of numbers, you start from 10, reducing by 2 up to negative 10. And then the y definitely is you sort out, you put all those numbers together, but you sort them from the lowest to the highest. Then I say normalize the function y. So what this function will do is it will just give me a normalized uh, uh, set of numbers, which is y that you have been given. And remember, these are my y values. So what I do is I put them in an interval of 0 to 1. This is also a function that is also used quite a lot in machine learning or data science when you're trying to normalize your numbers in some of the computations. Today we want to look at the R Markdown, how to do your documentation using the R software. In RStudio, I already have my document here, but I want to take you through the steps. If I go to File, then I go to New File, then I have many options that I'll pick, but I'll be interested in R Markdown. So I'll click on R Markdown. And once it opens, it gives me the options to put the title of my document, the name of the author, the date, or I can allow it to use a system date, and then I'll select the output that I would want. Is it a HTML if I want to move my work directly to a website? Is it a PDF? You must have mic tech the system that you're using, or do you want a Word document? So since I already set up one, I'll cancel, but if you had not set, you would have said okay. So after that, I'll get some details as indicated there. And then this is a default that comes about all setup include is equals to false. The neat all is the package OPTS chunk, and set echo is equals to true. I'll mention a little bit more about that. Now, this line 8 to 10 with the 3 dots here and these 3 is called a chunk, CHUNK. And I'll show you how to put up a chunk as you work. And the first thing we want to look at is basics in R. This is an introduction to R. We start with the basics of R in this section. And for me to introduce a chunk, and what is the purpose of a chunk? Whatever you put in the chunk is that will be executed by the R software. So it will be assumed to be a R code. Anything else you write out of the chunk is taken to be a normal statement. So we introduce a chunk, Control Alt I. If you Control Alt I in a R Markdown document, you get a chunk, you get something like this. So for example, if I wanted to introduce a chunk there, Control Alt I, I'll get that as a chunk. But since I already have chunks, I will not keep that. I'll move on with what I had. And I can rename from R to R basics. First of all, I want to generate numbers from 1 to 50 in a difference of 2. If I do that, you can see down here I have 1, 3, 5, and the last number is 49 because it should stop. I can get the square root of those numbers. I can get the square of them. I can also create a matrix which is appearing there. It's 1, 3, 5, 0. That's a matrix. I can create factors from gender as male and female, and I have them there. And it tells me the levels are female and male. So those are some of the basics. So everything inside the chunk will be executed by the system. Anything you write on the white spaces, then it will not be. The next thing we want to look at some of the data sets and packages in R. We have a number of data sets for use in R. So many of them. The Star Wars, which comes with the dplyr package. We have the datasets that comes with the R base. We have the ML bench package, contains so many datasets, Boston housing, Pima Indians, diabetes, etc. So because number 3 is a package, you have to install it, and then you'll be able to view that data. We'll use a few of them as we move along, and the list is endless. So one of the package you want to install, the dplyr package, the tidyverse, and the ML bench packages. One of the datasets we can easily pull is the iris dataset from the R base, and then we can also get the Star Wars, which is a called Star 1 from the dplyr package. The dplyr with the 2 colons, it means what is on the left is the package and what's on the right hand side is your data set. So based on that, we can do just some basic manipulation like data cleaning. And for us to be able to do that, and then we can look at these 3. So what we need to do is I need to read the packages because they are already installed. I can control enter through all of them, and I have them. I can view the data just for illustration purposes. I list 1, and I'll get my data there. It has 5 columns: sepal length, winged, petal length, and wings, and then the species. I can also view the star 1 data so that we see what type of data we are talking about. And that is the data that we have. We can see already there are some NAs in the hair color, and the birth year there is NA, not a number, that you need to be removed during data cleaning process. So at this point, we want now to take that data the Star Wars data, and I want to tell it to omit anything, na.omit, it will remove all the values that are not. So for example, if I now view star one clean, you see it is so leave for that and view. It will show me it has already, if I compare this, like the hair color, second and third entries, and number 8 are NA, and there you look, they have been removed. So what it does, it will remove the whole of number 2 from here to the end, number 3, and it's not normally the best way of cleaning the data, but what I wanted to illustrate is how you can remove NAs easily. So you find in the clean data, the NAs are no longer there. So now I want to do some basic tidyverse manipulations of the dplyr. So I can select 3 columns and I can tell it to give me a summary of the 3: sex, gender, and height. I can see clearly that height is a numerical data. I said here select sex, gender, and height, and we see that our data has, there is sex, there is gender, there is height there. And when you see sex and gender, it says they are character, but in real sense they shouldn't be characters because male is female, male, and none for sex, meaning they are categories. So this should be factor. The same with gender, masculine and feminine, it should also be factor. So we'll look at how to convert that. So I bring in the tidy all. I can also use the drop.na to clean up my data, and the tidy all package contains the drop.na function that can also do the same work that we have done. And you can check the classes of the data. The height is an integer, and clearly the other two, the sex and the gender, are character. So I want now to convert that. I use a mutate if. If the data, the column, sex, and gender is character, convert it as factor. And if the column height is integer, make it numeric. So if I did that and I come and say summary here of class height, it will tell me that it's numeric. Even if I was to say class, then I say star true, then I put in sex, it tells me a factor. Now what's the difference? Star 1, the data we call star 1, you see that it will tell me sex is a character, but now I've converted it into a factor using this simple command of mutate if. Then I can also change, if you look at our data like sex, the M is small, the F is small, and so I can make them capital letters using mutate at, and this is the function that I'll do in number 3, and then I'm going to rename. It says I could not find the function cg. Okay, it's a C, not a cg, so sorry for that. So it talks about being the dplyr being depreciated, but that's not a problem. So let's view star 3. You can see now my sex x, the column name is in capital, the first letter, title case, and then the variables that I have here, male, female, they are, it's capital M and capital F. So that's what I would have done using mutate at. And then I want to briefly look at some basic statistics, descriptive statistics, mean, mode, and so forth. And I will still want to use the data start that I cleaned. If I click there and there, one, if I check through the sex, I have 6 female and 23 male. If I look at gender and height, it compares the gender and the height, how many are in each height in the given data. That is something else that we could do. Or I could decide to select sex and height, and then I group by sex, and I want to count how many will appear and convert that into percentages. And if I check that down here, DESC1, it tells me that 6 are female, 23 are male, and out of all that, I see that is 21%, 6, 21%, and 23 is 79%. Why are we rounding it off? Because I don't want many decimal points. I want it to give me full numbers. So I'm saying group by, then summarize frequency. So this column here, frequency in the console, is freq is equals to n, and then PNCT is percent. You want to get the frequency, divide by the sum times and it to 1. You round it off to 1. I can plot that graph of the same information, and that's what we have. It's the only 2 dots for the female at 21, and then for the male at 79. And that's what we are saying here. I say take the data DESC1 as that x-axis should be sex, y-axis P and CT, which is the percentage. Use the geom point as that size is equals the percentage, and the color should be blue. And then you put a legend on your right hand side. Label the x-axis as sex, the y-axis as percentage, and then the GG title is the number of male and female. And if you plot that, that's what you'll get, their number of male and female as it is illustrated there. It's always good when you are doing R Markdown. It gives you the option to discuss your work, and that is some basic description I've given there. I could as well have decided to use the same data and plot a bar graph, the DESC1 data. The difference is now I'm called not a geom point, but it's geom bar. And I also said the geom text should be the percentage. So what's the difference with that and the previous one? Let's see where the difference comes in. Now it shows the percentage for the male and also for the female at 21, and it's a bar graph. And we have the legend, the sex, we have the female and the male. The y-axis is the percent. The label is given there, and so forth and so on. So that's what you can do to give yourself a plot or a visualization that you'll be happy with. You remember, you are doing everything here. So when you are going to need the document, which I'm going to show you in a while, then you'll be able to view your full document. We could do some little bit more descriptive statistics using the high-res dataset. I'm calling it, I want to use the neat al, and the purpose is now I want it to select 2 columns, sepal length, petal length, and petal wing, then the species, you group by species, and you summarize. If it's numeric, you give me a mean. So I'm saying summarize if is numeric. If my 2 columns are numeric, then it will give me the mean. After it's done, it gives me an output of a table using the carbo function, and this is what you get. So it gives me there the setosa. This is the IDs dataset. You can explore it a little bit more because it's part of your R base, and it tells, from there it tells me the species with the biggest petal length and the biggest petal width than the one with the smallest, just basically getting the mean. I could also do a small plot using the Q plot, not the GG plot this time, just to have a feel of difference. And you can already see, even from this illustration and the mean value that we found, it's very clear, evidently. The pinkish ones are the setosa, the green ones are the vesicala, and the blue one are the virginica. And that is the same information we were getting when we looked at the mean values. Let me go through to it again. and you'll be able to see that's exact information that is being. So I'm representing the information basically using graphs and also using values, and then I can do some discussions from them. I could also have decided to get the standard deviation, just saying SD, and then I output them. These are the standard deviation, and it's possible for them to combine them together, but we can look at that in another video. So these ones you are able to get also. So the purpose of the cable is to give you the results in a table format. They come with different formats. One of them is pipe, other one is simple, and so forth. There are so many different formats. If you are not sure which one to use, you can come, if you put a question mark here and say cable, then on your right hand side it will give you some of the other formats that exist that you can use. A little bit more on other ways of visualization or data visualization without using the ggplot. You can use the standard, I say hist. So I want to get the histogram for the iris data set for the sample length, and if I do that, it will give me some output here, and that is my output using an histogram for the same. And I can say the X lab is the sample length, the main is the histogram. I can also do a bar plot of the same data set. That's the bar plot using the three species. They are all 50-50 because that's how big your sample size was. I could do a box plot compared to length and the species. And what do I have? I have something similar to this. And definitely you can change the color and so on and so forth. I can also do a normal plot of two continuous values, sample length and sample width, and that is the graph that you get. You can come in and think about how to introduce the color. I think I could easily say color is equals to blue. I guess so. For example, I prefer blue. Can use any other color. The color is not picked. Maybe I'll need to confirm the command for that. So having said that, then you can now, if your document is working, you can either click neat here, yes, and you can specify. You have already specified initially. At the beginning, I'll show you where you specified what you want the output. Output should be a Word document, but still neat allows you to choose. You could have specified Word, but you wanted HTML. I go with Word, and then I'll show you the output. So now we want to look at the document that you have been working on. And so when I output my document in Word format, I'll get a document similar to this. You can add some more information because this is a Word document, so you can easily type. You can decide to go back and remove some of the sections that you are not happy with. So I've been able to come up with a document of 10 pages. You can resize some of these images. You can go back and edit so that when you need again, they come out in a more better fashion than they appear. This was the cable. That's how the table would appear. This was the histogram. This was the box plot. This was the different bar graph we had, and then this was the normal plot, which is a scatter plot. I didn't give any description. You can put up your story so that you are able to explain what your results mean to the person who will be looking at your document. So all these are at your disposal. It's you to decide how you want them to appear. And I think that gives you an idea of what is required when it comes to using the R Markdown, introducing the chunk and then being able to do your work.